Hey guys, it's Miss Avogard again. We're starting a new chapter today, chapter 11, section 1. It's called Exploring Solids. Welcome to 3 dimensions where things happen in real space. We're going to take a look at the polyhedron. Polyhedron is a 3-dimensional figure whose faces are polygons, like this guy here. A face is the polygons that make the polyhedron. So the face is just the polygons that make up our shape, our 3-dimensional shape. Our edge is where 2 faces intersect. And our vertex is where 3 or more edges intersect. Okay, so the vertex is like this little corner here. The face is this front, technically the side, top, back, left, and bottom are also a face. And the edge is the line that's created where the 2 faces intersect. And those 3 things make up a polyhedron. So 2 dimensions, it's a polygon. 3 dimensions, it's a polyhedron. Determine if the following solid is a polyhedron. So we're going to look at A. The requirements are the sides are made up of polygons. So we're just going to say are all these faces polygons? And the answer is yes. We look at B. Are the sides polygons? The answer is no, because polygons are they are bounded by edges and they meet at corners, and a circle is not at all a polygon. We look at this sphere shape here and we go, is there edges? Is there a face? The answer is no, it is not a polyhedron. Look at this little pyramid guy here. We got a square on the bottom, triangles on each side. All those items are polygons, so this guy is a yes. Regular versus convex. A regular, so a regular polyhedron, the faces are identical, regular polygons, and a convex polyhedron, any 2 points inside the polyhedron have a line segment joining them only inside the shape. So let's look here. All right, so if I were to draw a line, say we'll just go corner to corner, from right here to right here, that line would be totally inside of my polyhedron. But if I were to draw a line, say from this top line all the way down to this bottom corner, we go through our shape, out of our shape, and then touch our shape again. So any 2 points inside of a polyhedron have to be wholly inside our shape in order to be convex. If it's not the case, like this scenario right here, this is called concave. And I think of it like, well, it doesn't pass the line test. You can draw a line and it goes outside of you can draw a line from one point on your shape to another point on your shape and exit your shape. It's called concave. I go more basic than that. It looks like if I were out in the wilderness and I needed some shelter, I could shelter under this little cave area here. So that's how you remember concave and convex. All right, we are going to start slicing and dicing, so get your chopping knives out because we're going to look at cross section. So a cross section takes a plane, which is kind of like a thin slice of paper, and draws it through your solid. So we're going to look at 3 different scenarios. The scenario where I have like this little cube shape, and then I've got this piece of paper drawing through my cube shape. What cross section happens when I chop the cube with this piece of paper? And you're like, oh, it looks like a square. This cross section is a square. All right, we're going to look here. If you have trouble seeing it, just put a point at each intersection and then draw some lines. Like for this scenario, goes from here to here, from here to here, and from here to here. So we see that this cross section for B, it's a triangle. Sorry, my computer is singing to you. All right, and then when we cut a sphere anywhere with a sheet of paper, or otherwise known as a plane, you get a circle. All right, so now we're going to start naming and looking at different platonic shapes. Just so that you guys can remember, tetra, 1, 2, 3, 4, tetrahedron, cube, it has 6 sides, regular octahedron has 8 sides, regular dodecahedron has 12 sides, regular isosahedron has 20 sides. All right, so let's get some information down here. So a regular tetrahedron, if we count the faces, we got 1 on the front, 1 on the side, 1 on the back, and 1 on the bottom. It's 4. That's what the tetra comes in. It's vertices, so it has 1, 2, 3, 4 vertices. And edges, so if we just count the lines, it's 1, 2, 3, 4, 5, 6 edges. A cube, I know this one because I know on a dice, so anytime we do cube-related things, I think about rolling a dice. What dice are numbered 1 through 6, so it must have 6 faces. If you count up the corners, 1, 2, 3, 4, 5, 6, 7, 8, it has 8 vertices. And then the edges, we count up all of our edges, 1, 2, 3, 4 on the front, 1, 2, 3, 4 on the back, that's 8, 9, 10, 11, 12 edges. Okay, and it gets harder to count from here, so I'm just going to give you this information. Please write it down. There are 8 faces in an octahedron, that's why it gets the oct, like an octagon. The vertices are 6, and the edges are 12. A regular dodecagon, it has 12 faces, 20 vertices, and 30 edges. And then a regular isosahedron is 20 faces, 12 vertices or 12 corners, and 30 edges. There is a relationship. So you don't have to memorize all these. There's a relationship for the number of faces, vertices, and edges. So make sure you highlight this. It's your number of faces plus your vertices is equal to the number of edges plus 2. So if you look at our scenarios here, 4 plus 4 is 8. That is equal to 6 plus 2. Oh yeah, 6 plus 2 is 8. 6 plus 8 is 14. That is equal to 12 plus 2. 8 plus 6 is 14. That is equal to 12 plus 2. 12 plus 20 is 32. That is equal to 30 plus 2. And 20 plus 12, 32. That's equal to 30 plus 2. Okay, let's do, without a shape, let's go ahead and find the vertices. If we have 5 faces, 9 edges. I'm going to type this at this point. So we've got F plus B equals E plus 2. Okay, so it has 5 faces. We don't know the vertices, and it's got 9 edges. So we just make a little equation. So we got 5 plus B equals 11. We're going to subtract 5 from both sides. And we get B equals 6. So it has 6 vertices. We're going to do that one more time. I know, don't judge me. I'm just going to copy and paste it. So in this scenario, we have 20 faces, 12 vertices, and we don't know the edges. 20 plus 12 is 32. That's equal to the edges plus 2. So in this case, we're going to minus 2 from both sides to find that 30 is equal to our edges. Okay. A soccer ball is made up of 20 regular hexagons and 12 regular pentagons. How many vertices does it have? Okay, here. This is going to be exciting. You guys are going to love this. So what I want you to think about, like, oh, we know a hexagon has 6 sides, and we know we have 20 of those. We know a pentagon has 5 sides, and we have 12 of those. But the formula, Miss Applegarth, is F plus V equals E plus 2. All we know is how many faces we have. So how dare you? How dare you? Because we need a V and an E. So let me show you how to get the edges if you know how many faces there are. So we have 20 regular hexagons, and each of them has 6 sides. And so we're going to multiply 20 times 6. So we have 120 edges to our hexagons. We have 12 pentagons. Pentagon has 5. So we have 12 times 5. So 12 times 5 is 60. So altogether, there are 180 edges. But here's the fun thing. We have an overlapping of edges. Half of these share their edges with the other half of these. So anytime you are finding the edges, you take your shape, multiply it by how many you have on your polyhedron, find the total number of polygons, and then divide by 2 because of the overlapping. Okay, so there technically are 90 edges. All right, so we have 90 edges, and then if we add our 20 plus our 12 polygons, we know we have 32 faces. So this is going to be 32 plus b equals 90 plus 2, 32 plus b. I love it when the algebra is easy. Subtract 32 from both sides. B is equal to 60. We have 60 vertices. All right. Go ahead and take a moment. Work on the 11-1 practice. It's on page 692, 6 through 22 even, 31 to 33, 35, 38, 60, and 62. Here are all the practice problems worked out. And let me know if you have any questions.